up there, otherwise you crash your head on things all the time.
Is this more cramped in and out than other cockpits?
Yes, it is. Yeah, there's really not much spare space in here.
Okay, doke.
So I'll just go through, sort of roughly speaking, what a takeoff. Like having done all the takeoff checks, you've got the reheats pre-selected on, you've lined up on the runway. And using the nose wheel steering, I didn't point the nose wheel steering out, that's the steering handle for the nose wheel. And you've lined up on the runway, you've got your takeoff clearance, and when you get that, you go 3, 2, 1 now, and open the throttles up, start the stopwatch going, and off you go down the runway. And the non-handling pilot will call the speeds. He'll call V1, which is the decision speed. And that below that speed you can stop the aeroplane on the runway and bring it to a safe halt and get off the runway and then sort out what the problem was. After V1, if you've got a failure, you have to carry that failure into the air with you and then deal with it when you're safely climbing away. The next speed that the co-pilot calls is rotate, which is the speed at which the pilot flying it pulls back on the control column to a pre-calculated nose-up pitch angle to lift the airplane off into the air. And then after that we've got V2, which typically would be around 220 knots, and you're now climbing and accelerating. You bring the undercarriage up with that lever there, and then you initially climb away from the airport area at 250 knots. And as soon as you start accelerating above 250 knots to your subsonic climb speed, which was 400 knots, once you get to that point, you then bring the nose and visor up with this control here. That control switch would be down there for takeoff, and you then lift that control switch up into that position, which brings the nose into the fully up position. And then when you bring that control switch right up to the top where it is now, that brings the visor up from the nose and streamlines the sort of nose section of the airplane for supersonic flight. And that's really about it. When you get to the supersonic acceleration, you usually have a sort of short subsonic cruise where you fly along at 0.95 Mach number. And once you get your clearance to accelerate, I didn't mention the noise abatement, did I, in that? Sorry, I forgot about the noise abatement. The noise abatement side of it after takeoff, typically it's about a minute and 15 seconds after takeoff. The non-handling pilot will call 3, 2, 1 noise and the pre-calculated noise abatement cutoff time, and the flight engineer will then select the reheats off and bring the throttles back from that full power setting back to a predetermined setting that you've calculated before you started the takeoff, and you then tiptoe out past the built-up areas around Heathrow prior to then reinstating full dry power for your subsonic climb up to your subsonic cruise altitude. Once you get to the point where you accelerate to supersonic flight, which going from London to Kennedy Airport was west of Cardiff, out over the Bristol Channel. Once you've got that acceleration clearance, and that had to be a guaranteed clearance by air traffic, that you could do a seamless climb and acceleration right the way from 28,000 feet through Mach 1, the speed of sound, right the way up to 50,000 feet and Mach 2. You could not stop that process at any intermediate level because the drag levels would have been absolutely horrendous. The airplane would not have been efficient, the fuel flows would have been horrendous, and you'd have probably needed to have the reheats on to sort of keep the airplane flying sensibly, and yet there's a time limit on the use of the reheat, so you actually have to have a copper bottom guarantee from the air traffic controllers that you can do a seamless climb and acceleration right the way through from 28,000 feet up to 50,000 feet. And if they can't give you that assurance, you're actually better off delaying the climb and acceleration by 10 minutes or whatever, in order to avoid the conflicting traffic that's causing the problem, and then doing your acceleration later on. So you simply cannot sort of stop it in midstream. Anyway, now once you've got that acceleration and climb clearance, you open the throttles up fully,